Okay, hello everyone. Welcome to our usual monthly CoffeeJug online meetup. I'm happy to know that all of you here right now online and will participate in this amazing event. Today with us, Hugh McKee from Florida, and Hugh will talk about the evolution from Monolith to microservices, serverless, and beyond. That's actually amazing topic in nowadays. Welcome everyone. My name is Andriy, and let me talk a couple words about our community because the community is our main driver. That's the thing why we do this. That's the reason, and that's the actually goal to build this community, build healthy community, and known around the world. As you can see, we invite great speakers around the world, and that makes sense, a lot of sense for all of us. So today is our 11th event, and for during all this time we had 442 unique participants, and this number increasing consistently. However, like we would be happy to see this amount bigger and bigger, right? So please do this, share information about us, and here's like my team who's located right now near me, Ira and Ihor, and also Oles and Oleksiy, our program committee, the people who help speakers, young speakers, new speakers to prepare their talk, to do some trial runs. Also, the like very big or actually great thank you to Awenga company, our partner. Thank you very much to supporting Linux community. And thank you to JetBrains, our community partners who provide us yearly free licenses. And these licenses will be raffled out between all of you who will fill the feedback form. Also, today we would like to introduce activity bonus. We very miss you. We miss to eat croissants and drink coffee on a live event. So we decided those people who will ask questions, and our speaker, Hugh, will select one or two the best questions. We, CoffeeJug organizers, do ourselves commitment to give you a bonus. We will order some delivery service and deliver you some tasty croissants and coffee. So please ask questions, be active. So that's like our official part is done. Right now, we will switch to maintenance window. Hugh will prepare, and we will start very soon. Please follow us, join us, Facebook, Twitter, Instagram. Thank you, and see you soon. Enjoy.
Hi everyone, this is Hugh McKee. You mentioned, I'm in the US and Florida, home. Normally I travel a lot, but ever since this whole thing started with the virus, that's all stopped. So I really miss being able to come to places like the Ukraine and run into all the amazing developers in your country, as well as other places around the world. But hopefully one day we'll be back to that. I'm a developer advocate, and I work for Lightbend. And Lightbend is the company that some of you may be familiar with. If you're not, you may be familiar with things like the Scala programming language or the Akka distributed system toolkit, and things like the Play framework, Logon framework, and so on. Lightbend is the company that's behind all of those open source projects. We've got engineers, that work for Lightbend that are the stewards and contributors to all these different open source initiatives, projects. And in addition to that, we have other offerings where commercial offers and so on. That's how we make our money as a company. But today, I wanted to do this talk on the evolution that we're kind of going through at this point. I've done this talk a few times at different conferences. I did it a few times starting last year, and it's always been really interesting because as people like us that are involved in the development of systems and the use of different technologies, each of us individually are kind of all over the place in terms of some of us are doing very advanced, kind of cutting edge things like serverless is kind of the cutting edge thing these days. And others, on the other hand, could be, back doing things that we've been doing for quite a long time, like working on Monolith and so on. But there's this broad technical landscape that we're in these days with what we commonly refer to as monoliths and microservices and serverless. And then at the end, I'd like to talk a little bit about maybe what might be coming. And I always say I'm going to make myself look like a fool, because trying to predict the future in our business, the way things move so quickly, is pretty much impossible. But I will at least maybe say a few things about where it would be nice to see how things are heading as technology moves on, as it always does. So the idea is that I'm going to be using this kind of visual landscape here. This whole slide deck is in this 3D view of things, and the different shapes represent the different things I'm going to talk about. So first on the very left is the monolith. So I have this single this rectangular box that represents the monolith, and then next to that is a bunch of smaller boxes that represent, say, a microservice system. And then next to that is even smaller boxes that represent, say, a serverless system. And then, as I mentioned, I'll go into a little bit about maybe some things that are coming down the road. But the idea for this, the inspiration for doing this presentation in kind of this 3D way was to show things, show things from this visual perspective. And one thing that, and this was really the real motivation for doing this picture like this, is that when you look at this, you see the monolith on the left, you see the microservices, a little bit more, a bunch of smaller boxes, and then you see the serverless on the right, which, there's a change in granularity, and granularity in the way we develop code. So with monoliths, the whole point of it being called a monolith is that it's an entire system, maybe an entire application that's written as a single unit of code, and it's deployed as a single unit. But then you go to a finer grained approach, and you have things like microservices, where the idea is that instead of doing a single deployment for say a new version of the application, that you have individual microservices, and they can be deployed at their own rate. So say you're working on a microservice team, and your microservice is changing quite rapidly, so you deploy quite rapidly. And maybe you're working on some of the microservices in this picture here. And then say I'm working on another team, and maybe we're not going as quickly. We don't need to deploy as often. Well, the whole point of this is that we want to make it easy for us to deploy the parts of the system that need to be deployed when they're ready to be deployed. And then serverless takes it even another level, where you're going either more fine-grained units of deployment, and it's just carrying this principle forward of kind of going from coarse-grained granularity of developing and deploying software to finer-grained levels of granularity. But the one question is, well, why are we doing this? Well, it's cool to do these different things, but there's got to be a better reason. We got to justify to our management, to our business, to our customers, why are we making these fairly radical technology changes? And I think the answer is that the justification is that it's allowing us to do things more quickly. And I like the term innovation velocity. And what I mean by innovation velocity is that you're getting features out into production that matter to your business, that matter to your customers at a faster rate. I've been developing software for a long time. I definitely grew up a lot, like from the early 2000s, 2010s. I view that as the period of the monolith. And I was working at IT in IT at Hewlett Packard at the time, working in application systems and building monoliths. And we were on fairly long release cycles, like every 6 or 9 months. And that's the way we did things. So from that perspective, or in that kind of environment, our business and our users, our customers, didn't see new features, or they only saw new features every 6 months. Well, that's not acceptable today. Today we want to move much, much more quickly. So really, the way I look at it is that the reason for moving to these finer grained levels of deployment and these finer grained ways of building systems is really about allowing us to build features and deploy features at a much higher rate. Some of the characteristics of this, though, is that, and this is a challenge because it's sometimes hard to let go of the ways we have been doing things and adopting new ways of doing things. But a big part of this granularity is that in order to have that agility, that ability to deploy finer grained pieces of software more quickly, is that each one of these, more finer grained things, each microservice, each serverless function should be as independent as possible, meaning that there should be few, if any, inhibitors from the ability to deploy a change to one of these things without having to cause a kind of a ripple effect. This is one of the fundamental challenges with monoliths, is that, say you want to introduce a small feature in a monolith and get it into production. Well, that means you've got to release a whole new version of the monolith, run all the tests and do everything, and then do the deployment. This is one of the big benefits of going to these more fine-grained ways of doing things. Also, another, I think, really important characteristic is that these independent components, microservices or serverless functions, need to be loosely coupled. And I'll go into what I mean by loosely coupled as we go through some of this presentation here. So the monolith, the idea with the monolith is that it's just this one big unit. Now, every time I think of the term monolith, I always think of this shape, and the shape is it's 1 by 4 by 9. It's 1 deep, 4 wide, and 9 high. That's the ratio of the sides. The inspiration for this, if you're a science fiction geek, then you probably recognize this shape. If you, so I'm hoping some of you know that this is inspired by a legendary science fiction movie that's over 50 years old, by the way, 2001: A Space Odyssey. What's also funny, though, as I mentioned, I'll try to do a little prediction. 2001 came out in 1968. It was an amazing movie. It still is an amazing movie, even today. The special effects and everything, I think, even though it's over 50 years old, it's still pretty spectacular. But this was 1968, predicting what things would be like in 2001. And if you've seen the movie, you know that the view of what 2001 from the perspective of 1968 didn't match reality at all. And this is the folly, or the risk that you take when you try and predict the future, is you're probably always going to be wrong, because the future takes its own course, and no matter how we try to predict it. So in any case, the monolith is the idea is that it's really composed of a bunch of modules, and I've heard it said that in the discussion about moving from monoliths to microservices, I've heard it said that what makes you think if you can't properly modularize your monolith that you can build a bunch of microservices to replace it? And that's a good point, but I think a counter to that is that the tools that we've used to build monoliths didn't really lend themselves to modularization. By modularization, I mean it means like again, instead of you and I working on different microservices, say I work on one module of the monolith and you work on another module of the monolith, and we want to isolate those two modules from each other as much as possible. But it's very difficult for me, say, to isolate my parts of my module from you. I mean, I can, if we're doing development in Java, for example, I can use some of the features in Java to hide some of the code so that you know externally you can't see it. But until recently, with the introduction of modules, for example, in Java, it just hasn't been that practical. And there's just the physical presence of each other. All this code is compiled as one big unit, and it's difficult to really have clean separation between the modules within a monolith. But there you have it. You know, the monolith is composed of a collection of modules, say. Before I move on to microservices, though, one thing I think that's interesting is that, you know, say you're like when I worked at Hewlett Packard in IT, we had a large collection of applications that were used within the company. And there was this one initiative that happened back around 2010 or so when we were doing some big modernization, and it was to get a catalog of all the applications in the company. And the catalog came down to be around 1,500 to 2,000 applications. Hewlett Packard at the time was around 350,000 employees. It was a big company at that point. So here I'm just showing a landscape of 1,000, 25 by 40 monoliths. So if you look at it from this perspective, that's pretty fine grained. HP as an enterprise at one point had more than this. And when you're looking at, say, breaking your monoliths down into finer grained software components that deploy into some kind of production environment, the number goes way up. So just to kind of put things in perspective a little bit. But in any case, moving on to microservices. So the idea with microservices is that you're replacing the functionality, say, or you're implementing the functionality that had been, or in the past we would have implemented as a monolith, but now we're implementing it as a distributed set of individual services. And so one approach is that you take the monolith and you kind of break it up, break up those modules, identify the modules, and then you start building a microservice system. And maybe you don't replace the entire monolith at first with microservices. Maybe you go gradually. So here I'm showing you have a full monolith, and then we introduce a few microservices that replace some of the functionality. And then maybe over time, as you get more comfortable with the technologies and the tools and the processes for building a microservice type of system, you start introducing more and more. And ultimately, you go to where you've replaced your monolith. You've got a full microservice system. This just in general. I mean, it's not the only approach for introducing microservices into, say, a company that has a legacy of monolithic applications. But it continues on. I mean, with microservices, it's a level of granularity, and going from microservices to serverless is you kind of going down granularity again. Now, I'm not saying it's like for every microservice there's going to be 8 serverless functions. I'm just saying that typically the level of granularity of a serverless function is typically, not always, but typically less than the typical microservice, if there really is what we would consider to be a typical microservice. I've also heard, though, that people kind of thinking, talking about serverless functions as microservices. So but in general, the level of granularity does go down. So then there's serverless, and then we're going down to another level of granularity, typically. Now, the whole serverless thing was kind of started by Amazon with the AWS Lambdas, and I think it was around the 2014 or so timeframe that they introduced it to the world. And since then, though, things have really caught on, and they're definitely not the only player in town. And so Google, Microsoft, IBM, others have all seen the value in this approach for building a system, and they're all in a way, in one form or another, providing solutions that allow people to build what would be considered to be serverless types of applications. And the general term, instead of a Lambda, is called function as a service. But serverless, why the term serverless? And because it's like, you always hear, if you read an article or something like that, or listen to a talk, somebody says, well, we have to have stuff, someplace to run our code. So there's still servers there somewhere, but there's a different, it's a kind of a difference in abstraction in a way. And what I mean by that is that in the pre-serverless world, especially in the monolithic world, we had to think about capacity. And this is one of the things I always dreaded on the projects that I worked on, is at some point, we say we're working on a new application or even an existing application, and we're making changes to it and adding more features or whatever. But the question comes, well, how much capacity will this application need to run? And that's a difficult question to answer. So here I'm trying to show that in one way to think about capacity is in these two dimensions. And one dimension is the CPU or processing capacity. So this is across the bottom here, the CPU axis on this. The other dimension is how much memory do you need? So, like I said, when I was working on monolithic applications, they would ask the question, well, how big of a server do you need? A virtual machine or whatever. How many machines do you need? And the reason why the question was difficult was that you had to think about, well, how much capacity do I need when this system gets busy? And that's where it gets tricky, because here I'm showing, all right, so we have this, say we make a decision, we need so many CPUs, like 16 CPUs and 64 gig of memory, for example, just to pick a number. And all right, so we made our decision. So now we start running our whatever, our monolith, our service, or services or whatever we're running in it. So this green box represents a running process. And it's running, and it consumes a certain, depending on what it's doing at every point in time, it's consuming a little bit of CPU, it's consuming some memory. But that changes over time. It goes up, it goes down, depending on the traffic. Say during the day, the application's real busy, and at night it's not. Maybe on the weekends it's not busy. Other applications it's busy on the weekends, but it's not busy during the week. Who knows? But the problem is that it's running along, and you have to have sufficient capacity to handle a spike like this. What's an adequate amount of capacity where when you hit a peak load period, do you have sufficient capacity where the system will behave well during that peak load period? And there's legendary situations where the spike, the peak loads happen, say, and seasonally, at different times of the year, like the legendary shopping seasons, where, say, you have Black Friday or Cyber Monday, those things where it's right before a big gift purchasing time, and everybody gets online on that day or on those days, and there's a huge uptick in traffic. And often in the news, there'll be different companies that went offline at these critical times because they didn't have sufficient capacity to handle the load. And this is what I'm trying to show here, is that you have to have that sufficient capacity. But then, okay, so we're past that spike. And now we're running along and we got way more capacity than we need most of the time. So here I'm showing the process continuing around. We're nowhere near a peak load. It's still jumping around, eating up some capacity. Maybe there's another little minor spike, but nothing major. So we're just jumping around. So the end result is that, and this is a pretty consistent number, is that on average, with this kind of an approach, the overall utilization of the processing capacity is around 10%. I first heard this number back when I was at Hewlett Packard. HP made the servers. We're a hardware company, and we had IT centers distributed around the world where we had tens of thousands of individual bare metal machines, virtual machines, running on top of them, and so we knew how much utilization we were getting out of all those millions and millions of dollars worth of infrastructure, and it was around 10%. It drove my management crazy because it's like, why do we have all this hardware if we're only using 10% of it all the time? Well, it was because every single application had to go through this same kind of process to make sure they had sufficient capacity for their spikes, for their peak loads. And it didn't matter when we went to the cloud. The cloud basically is initially when we went to the cloud and you started, it was nice because you could just provision individual virtual machines basically in the cloud. But the same situation was happening, that we're running processes on those things. All that capacity had those two dimensions. Now, of course, things like Amazon, and others had some ability to give you some elasticity where you could spin up or spin down cloud virtual machines as needed, and it was much easier than doing it. Say, if you were looking for in say your own data center, where can I run? I need more capacity. Like right now, where can I get it? Well, often you couldn't. But overall, even in the cloud, the utilization still is around 10%. I mean, and what I mean by this is that if you're, say, using cloud virtual machines, you have to provision them. You're basically buying or renting how much CPU capacity they have, how much memory capacity they have, and you're paying for that, right? The meter is running, but you're trying to scale it to the point where it has sufficient capacity to handle your spikes. Now, Kubernetes comes along. Kubernetes is really cool, makes things better, but the game has still not changed that much, because even in Kubernetes, with Kubernetes, you have a cluster of Kubernetes nodes, which is basically a cluster of those two-dimensional boxes. Each box has one dimension of processing capacity, CPU capacity, on the other dimension of memory capacity. So when you run something in Kubernetes, it's run as a container in a pod. A pod can run one or more containers. Well, guess what? When you describe something to Kubernetes that you want to run, one of the characteristics that you have to describe to Kubernetes is you need to request a certain amount of CPU and a certain amount of memory, and you can also set limits on how much CPU or memory each individual pod will use, because Kubernetes is playing the same game basically. Every time you run something in a Kubernetes environment, it's trying to figure out, where can I run this thing in my Kubernetes cluster? So at least you get the ability to maybe better utilize the nodes in a cluster, but it's still playing that game that, if you have an on-premise Kubernetes, the on-premise Kubernetes has a finite amount of capacity. You have to buy the hardware that the Kubernetes cluster runs on. Is there sufficient capacity? Are we paying for too much? Do we not have enough? That you're still playing that kind of game. So here I'm showing the Kubernetes environment where like the first node, I'm showing 3 full nodes here. The first node on the left is fully utilized because all the CPU capacity has been requested by the pods that are running on that particular node. The first 2 nodes have some excess capacity that can run some more nodes, but basically Kubernetes is playing the game of you request to run a pod, and then Kubernetes figures out where to run it in its cluster. So we still have that, the two-dimensional capacity game that we're playing here. And this is the big thing that's changed with serverless, is that the idea is that, as from our perspective, and what I mean by this is by the developers, the architects, the operations teams, and so on, the people that are using the serverless environment, where things run and how the infrastructure is used, there's another layer of abstraction basically that is provided, where we basically say, here's my function. Here are the parameters for how it can run. Typically, like, there's a limit on how many instances of this function can be running, like how much memory, how much CPU can it consume, because you pay for that, but you have no knowledge at all about the infrastructure underneath that it runs on. So everything's still running on those underlying machines, but they've all been abstracted away. Kubernetes took it one step. Serverless takes it another step further. And this is, I think, the inspiration for the name serverless. So before I want to move back to the monoliths and kind of go a little bit deeper into some of these things. And I want to bring in storage or persistence, because with a monolith, when we think about, say, replacing a monolith with a microservice system or replacing a monolith with a serverless system, there's one aspect of thinking about how do we recode, how do we code the monolith, or how do we implement all the functionality that this application needs using microservices or serverless at the software development level. But there's also the database level, the persistence level. And this is what I mean by this storage. So typically with a monolith, there's a monolithic hunk of code and there's a monolithic database. Often what happens when people move initially to a microservice environment, it's relatively easy in many cases, not all, but in many cases, to break up the code. But it's often, not always, much, much harder, say, to break up an existing monolithic database. So the end result is that you have a system like this. What I'm trying to show here is a microservice system. So you've got some level of loose coupling and broken down the code into individual microservices, but they're all talking to the same database. And so they're all kind of basically wired together in a way. And this is a form of coupling, because say, for example, you and I are working on one of these microservices and we need to make some kind of a schema change. And since the schema is shared by all the other microservices, now we have to find out, well, the changes that we're considering to make, who will be impacted by those changes? And we have to find them, we have to talk to them, we have to negotiate with them about making these changes. We have to maybe coordinate with them, because if we change the schema, that might require them to change their code, which means we may have to do a coordinated deployment when everything's ready, and so on. So we still have some of that monolithic characteristic here because we still have a monolithic database. Now, I'm not saying this is a bad thing. I'm just saying there's a cost, but you're definitely moving in the right direction. So I think this is a very common approach. I think it's getting better. Over the last few years, things have continued to get better, but it's not bad because you're moving in the right direction. So don't feel bad if you have, say, a nice new microservice system, but you still have a monolithic database, because you are moving in the right direction. You are getting to the point where, more often than not, you can do deployments and you can be independently deployable, and you've done some level of reducing the coupling between, say, the module functionality that's in one microservice and all the other microservices. But the goal is you really want to have loosely coupled microservices. So that means you have to consider not only the code, but the data. So the idea is that each microservice should own its own schema. So I'm not saying that, everybody has their own database and their own database management system and all that kind of stuff. Maybe everybody's on Postgres. You like Postgres. You have a great team for supporting Postgres or whatever. I'm not saying what I'm saying is it's not the technology. It's the logical grouping, so that the schema is owned by each individual microservice. So that means that, going back to that scenario, you and I are working on one microservice, and we want to change the schema of one of these microservices. We know nobody else, none of the other microservices know what our schema looks like, because it's our schema. It's private to the microservice we're working on. That's a form of loose coupling. So the idea is that you think of every microservice really as, there's a perspective of the microservice on the outside, and there's a different perspective of the microservice on the inside. So that's why I put up kind of a black box over one of these microservices, that it's the code and the data, the code and the schema that are on the inside of the microservice. So the real goal is to have a microservice system that really is kind of composed of these very loosely coupled black boxes, basically. That they're independent boxes, code down to data, code down to schema. But here's another pattern I wanted to show. So I took the microservice system and I arranged all the microservices in a circle. And the reason for this is that, when they're in a circle like that, each individual microservice can see all the other microservices in the circle. They're all within view. So here's an example. Say the microservice on the bottom, where all these, these lines are connected to, is connected to these 4 microservices towards the top. So this is a very common pattern where, say, the 4 microservices on the top are using some kind of RESTful operation with the microservice on the bottom to maybe interact with this microservice on the bottom. So four microservices on the top are talking to the microservice on the bottom using REST. Really easy to do. It's very easy to implement. Everything's cool, right? Well, this is a form of coupling, though, and it's a form of coupling from the development standpoint, but it's also a form of coupling from a production standpoint. And what I mean by that is that, say the microservice on the bottom goes down, or maybe it slows down, which could actually even be worse. And that has an impact on the 4 microservices that are coupled to it, that depend on this other microservice. So say when the microservice on the bottom goes down, the impact is that it could mean that there's a cascading failure. The microservice, the 4 microservices on the top, maybe are also essentially down because they can't do the work. If they can't talk to the microservice on the bottom, they're down as well. So one failure cascades into other failures, which might cascade into more failures. This is like I said, it's easy to implement. It's a common pattern. It's not a bad pattern, but you should understand what the costs might be. So if you have a service go down, what will happen to the rest of the system? And usually when I talk about system architecture at this level, I usually like to say, I know, of course, this is in English, but what I'm saying is that don't use the word if. Change the word if to when. So it's not if the microservice on the bottom goes down, it's when the microservice on the bottom goes down. What impact does that have on the system? It's just a play on words, but it kind of has an effect on the way we think about the system. It's like, all right, we're say all of us were working on the design of the system, and somebody says, well, all right, this is your design. Let me ask some questions like, all right, what's going to happen when that microservice on the bottom goes down? How is the rest of the system going to behave? And if everybody goes, well, those other 4 microservices are down as well, and we all look and go, all right, how often is that going to happen? And is that an acceptable level of risk? When these things, not if, but when these things happen, how much of an impact will it have on the business? How much of an impact will it have on the customers and so on? The reason for bringing this up is that there are different ways of implementing microservice systems that don't have this form of coupling, which is what I wanted to show here. So here I've taken the same set of microservices, but I arranged them where all these microservices are connected in one way or another to some kind of a message bus, like Kafka, for example. And there's all kinds of different topics that these microservices can use to communicate. Now, the difference is that the communication here is more synchronous, where the microservices on the top send in a request to the microservice on the bottom, and then they get a response when the microservice on the bottom does whatever it was asked to do. In this scenario with the message bus, the idea is that the messaging is asynchronous. So this is what I want to show just real quickly here in a few minutes is this flow. So say this is a system, and just for fun, I've kind of flagged some of these services with lighter color as what I call analytic services, but it's really not that important for the sake of this discussion. So say I'm pointing an arrow at this one microservice on the left, and it's running along, and something happens in it, and it goes, oh, I need to publish a message to a topic. So it publishes a message. Later on, say these other three services are subscribers to that topic, so they consume that message. Now they consume at their own rate. It's not like it's all lockstep. But say we're just in this conversation. Something happens in the first microservice, it decides to publish a message, and at some time later, these other microservices pick it up. This is an asynchronous flow. So there's this kind of flow of going on, publish and consume. And then one of these services has been picking up these messages, and all of a sudden it goes, hey, something interesting happened in me, and I'm going to publish a message. So it's publishing a message to a different topic, say. And it just so happens that there's other microservices that are consumers from that topic, the second topic, which happens to be the service that I started with, the one with the arrow on it. So this could be like a fraud detection scenario. Like, say this service is going along, customer actions are occurring. This service on the right has been watching that. It goes, oh, I see, I've detected some fraudulent activity. I'm going to publish a message that say my account looks like it's been compromised. And it publishes that information to the topic. These other services pick that up because they're interested in fraudulent activity. So the microservice on the top that generated the initial data now has gotten some feedback. But the point here is that the communication flow is all asynchronous as a form of looser coupling. To make an example of that, say this service on the bottom right that I've kind of grayed out with the arrow pointing at it is down. We run through the same scenario. The service on the left is publishing. The other two services are consuming pretty quickly, but the one service that's down is falling behind. But this isn't a tragedy for this system, because when this service does eventually come back online, it just catches up. It starts consuming from that topic and it catches up. So this is just a really simple example, but it's kind of what I'm trying to show is kind of the different ways of doing communication between services, kind of the synchronous RESTful form of communication versus the asynchronous message bus, Kafka, or a queue or whatever you want to use for communication, but it's more asynchronous. It's a form of looser coupling. Now with serverless, back in serverless, I want to end up here just with just a little bit of some of the things that are going on with serverless. I'm sure some of you know way more than I do about serverless, but I just show a few pictures here. So this is just a simple diagram of, say, a serverless function, and I'm calling it a synchronous function because on the top it's getting a request in, which triggers this function to do something. It may read or write to, say, something else, maybe to it, to and from some topics, or read and write to a database or whatever, but it's doing some kind of work, and then it's sending back a response. So this is what all this function does. You write this function, you deploy it to a serverless environment, it starts receiving incoming requests, does some work, maybe does some IOs, and then sends back a response. And that's all it does. Another form, though, that's somewhat similar is that instead of, say, being linked in to maybe get messages directly from the outside world via HTTP or TCP or some kind of communication protocol, it's a function that is consuming messages off of a topic, processing it, maybe doing some IO as well, maybe updating some other database or something, and then maybe it's publishing out something else to another topic. So it's subscribing to topic A, does some work, maybe does some IO, persistence, whatever, and then publishing to topic B. So this is it's a kind of a form of a asynchronous function. And then maybe that, kind of a hybrid on the synchronous is that you're still getting, say, request responses, flowing through the function, but maybe it's also publishing to a topic as a side effect. So there's kind of this pattern here that's really getting interesting. And I've seen, for example, some presentations by folks from Amazon, talking about some of the really marvelous things they're doing with serverless there. And you start to see this pattern where they're talking about you're taking multiple different functions and you're kind of stringing them together, basically. You're building up kind of this system where things can plug together. So it's almost like this I'm showing kind of in this diagram where you can kind of take these little circles at the end of the lines and plug them together to snap together a series of functions that does a series of work. This is a real common pattern where, say you have, the function on the left is maybe getting some, request response from the outside world, and maybe it's writing something, like the example that I see often is maybe it's pushing something out to Amazon S3 or DynamoDB or whatever, your favorite form of doing persistence in Amazon. But many of their databases now are plugged into as a message bus. So as things happen, say you push something to a bucket in S3, well, that triggers a message that goes downstream to another function. So you kind of get this trigger flow. The first function does a little bit of work, and then something gets published, and another function picks it up and does a little bit of work, and maybe it publishes something down the line to another topic, and on it goes. So you start to string these functions together in something like this, where you got this kind of asynchronous flow. On the very left is maybe you're getting synchronous request responses from the outside world, but then it flows through a series of different functions that does the work that needs to get done in response to, say, the initial request. So that kind of gets me towards the end here, to the and beyond part. And it's really, the and beyond is with serverless. So one thing, and this has already started to happen in one form or another, but instead of having, say, the IO to the outside world only happening on the function on the left, the idea is that the input is, say, red and the output is green. Well, maybe it would be nice if the output didn't have to be in that first function. Maybe the input happens on a function on the left and it cascades through a series of other functions that do different pieces of work. But then maybe one of the functions downstream wants to talk to that outside world device, for example, to a person on a phone, or to maybe some IoT device. This is something that's already started to happen, and I think it's going to be a very powerful pattern. So maybe you do have this way of doing things where different functions could send back results as things flow through a series of functions. Another big one that's happening, typically when you hear about serverless, it's often thought to be stateless, that it's a stateless pattern, that each function has no state. It's actually turning out, though, that there's a lot of activity in stateful function work. And the reason I'm bringing it up is this is something that at Lightbend we're very involved in. And I'll tell you a little bit more about it in a minute. But the idea is that instead of doing like stateless CRUD, which I'm showing here, a request comes in, you retrieve the state from a database, you make some change to the state, and then you push the change state back down to the database and then send back a response. That you have something like this, where there are individual functions, instances of the function, and each instance of the function has its own state. So say like a shopping cart application, that say you and I are both buying something. We're both interacting with a shopping system. So I have an active shopping cart, I'm adding items to it, I'm removing and I'm changing things in the shopping cart. You're adding items and making changes to your shopping cart. Each one of us on the backend system has what's called a stateful entity, which is a stateful function that has basically the state of our shopping carts in it. So as we make changes to it, it doesn't require that we have to retrieve the state from a database every single time. It's that the state's already in memory. So it's a form of optimization to allow systems to run more quickly and other things. But from a development standpoint, it's really a form of a kind of event-driven types of development. So this is a very active area in research and in development. Microsoft is doing some things, and some other companies are doing some things that are really interesting in a more stateful type of serverless types of architectures. So this is one of the big new things that I think that are coming along. To wrap up, though, I think what's really interesting is that, to me, these kinds of systems where we have these finer and finer grained functions, and these functions are strung together, it feels more organic. And this is why I grabbed this picture. These circles say represent functions, and these functions are wired together, each one of them doing a little bit, but they work together as a whole to be the system. And that's exactly the way nature works. The ultimate computers right now on the planet are the computers on our heads, in our heads. And those computers are basically written and work in this way, very fine-grained, very loosely coupled units of computation that work together collaboratively. So it just feels like, over the years, we're going to be moving more towards a much more organic type of computing model. So that's it. That's the tour. I hope you found it interesting. The two projects that I talked about, the Lightbend project for stateful serverless is called Cloud State IO. It's an open source project. There's another one called State Fun, and then there's Microsoft is doing one as well. If you just do a search on stateful serverless, it'll be there. I'm sure you'll find it. But Microsoft is doing some really interesting things also. But so are we at Lightbend, and others also. StateFun is another project altogether, not affiliated with Lightbend, not affiliated with Microsoft. And these slides are at this link. So that's it. Thank you very much, and I'll open it up to questions.
Thank you very much, Hugh. We have like 20 seconds of delay between the stream on YouTube and the actual call. Let's wait a couple seconds and let our participant to hear your talk till the end. Probably some question will be raised. Yeah, actually, that was a great talk, and thank you so much. Even for myself, it was very useful for me too. And I would like to remind our participant that we have some bonuses for everyone who will ask questions, and for the best questions, it's a first of all, right? So, yeah, let's wait a couple seconds.
Yeah, questions are always fun.
Okay, I see the first question from Andrei Levchenko. The question is how to know when is a good time to move from microservices to the serverless?
Okay, well, that's a good question. So, um, the it's hard though because everybody's situation is different. The I think the interesting thing about serverless is the effort that it takes each one of us to adopt it as say a new technology. I mean, if you've been doing software development for a while, and say maybe you did work on monoliths for a while, and then you got a chance to work on microservices, so there was all kinds of new things that we had to learn there, and then now we're moving towards serverless. The thing that I think is exciting about serverless is that I actually like the term frictionless better than serverless. And the reason I say friction is the resistance to change, the resistance to movement. And with serverless, I think what's really interesting is that any one of us as a developer can set up an account with our favorite cloud provider, Amazon or Google or Microsoft or whoever, and start playing with the technology. There's tutorials and there's all kinds of documentation and videos on YouTube and so on about maybe trying some things with serverless. And it seems to me like the amount of friction, the effort that it takes to become productive in some of the serverless technologies is significantly reduced. Now, there's still a lot for us to learn because it's a different way for us to design and build and implement a system. But I think the opportunities for adoption are much better, and the friction is less. So that's why I like the term frictionless. So I think the thing to do is just like with any new technology is you find if you look for an opportunity. You're always so maybe the first thing to do is to try play with it a little bit, get comfortable with it, and then wait for an opportunity in wherever you work. If you work for a company or if you work for a service provider, maybe you're an independent consultant, wait for some kind of opportunity where it's like everything looks good and it's like, well, somebody proposes that, hey, this might be a really good application for us to try serverless. And so the big advantages, I think, are it's potentially going to change how you build your application. It's going to change how you pay for your application because you're only paying for what you're using, which is very different than having to pay for the infrastructure up front. Even if you're in the cloud, you still have to set up virtual machines that are running and you're paying for them no matter how much you're using them or not. With serverless, you're only paying for what you're using. So that's another nice thing with development. You try something, you run it, you're only paying for when you run it. Maybe you run some kind of a load test, so you have a spike in traffic. So maybe you pay a little bit more while that load test is running, but as soon as you shut the load test down, you're not paying for anything. But I think the thing to be cautious of is like, how would you actually build an application using a bunch of these, individual functions, because I know like with microservices, one of the struggles has been giving up on the monolithic thinking and moving towards a distributed way of thinking. So this is why earlier I brought up in the talk the request response, the synchronous type of approach versus the async. The old ways, synchronous is really a form of a remote procedure call. You call a procedure and you wait for a response. Asynchronous is a newer way, but it's foreign to us. It's different, and often people struggle with that in trying to think about how do I design an application using this asynchronous approach, and they fall back on what they know, and so they build, kind of these remote procedure call kinds of applications. Again, it's a step in the right direction, but you're still embracing the old ways of doing things instead of really embracing the new ways. And serverless, I think, takes it even further, where you really start to have to embrace the new ways of doing things. It's a great question, but I don't, not an easy answer.
Cool, thank you, Hugh. And we have another question. How can we be sure that serverless application is secure? That's the question from Yuri Stachniak.
That's another good one. I mean, you always have to worry about security. There's the security around the edge of the application, and there's security within the application. I think the nice thing, for the most part, with the cloud providers, they've always had to deal with security. This is one of the big challenges they've had in the way how they attract customers to use cloud systems, and now cloud, serverless cloud systems is just another form of a cloud system. So in general, I think the security features that are available are very, very, very advanced compared to, say, the non-cloud environments. So I don't think that, like, the security between, say, a serverless system and the outside world doesn't really change that much. You still have to have ways of authenticating users, authorizing users, authenticating whatever, things that are coming in from the outside world coming into your system, authorizing those things to interact with your system. You still have that kind of that same kind of boundary, and that boundary really doesn't change, say, between serverless and non-serverless. Inside, I really don't know enough about, say, the security between individual serverless functions, other than, things like there's always the fairly fine-grained security mechanisms available from the cloud providers. I remember sitting in once on this is a few years back, but I remember sitting once in from a Microsoft presentation on all the different security features they had built into their cloud, and I was just so impressed. It's like this is, people worry about security in the cloud, but it's like, wow, the security is so much better than what I ever saw outside of the cloud. It was incredible. Now, I know another thing, though, is that many companies, the data can't leave a certain geography, or maybe the processing and the data can't leave a certain facility. So the good news there is that I think with things like Kubernetes and serverless features that are being built on top of Kubernetes, and you can run those things on premise, that you get a lot of the nice features of, say, cloud computing and serverless computing on premise, as well as in some kind of a public cloud.
Cool, thank you, Hugh, for this answer. And actually, I don't see any other questions. Let's wait, I don't know, probably 10 more seconds. And if there are no other questions, then I hope we are done and can switch to the closing ceremony. Okay. Okay, thank you very much, everyone, for joining this event. Thank you so much, Hugh. Thank you for your time. Thank you for participating on our CoffeeJug online event. It was a great experience to have you here. Hope after this coronavirus issues, we will meet each other on a real life on some conference or I don't know anywhere else. It would be great because it's like really a lot of time ago we see each other. So thank you so much, Hugh. Thank you to our partner Avenga. Thank you so much for supporting Lviv's community. It's a big deal, I guess. Thank you. And thank you, JetBrains, for giving us a chance to raffle out licenses between our participants. But attention, it will be raffle out between everyone who filled the feedback form. Please don't forget to do this and share your impression. Also, we have like two comments, and I guess there shouldn't be any better. Both of them, Andriy Levchenko and Yuri Stakhniak, are the winner, and we will do our best to deliver you the tasty croissants and coffee. So please contact us via Facebook. Just type on our page, and we will contact you to bring these things, to bring this bonus. Thank you so much to be active on our event. And thank you, everyone. Join us and follow us because it would be much more events in future every month. And we really miss you and looking forward to seeing you in a real life, not only online. Hope it would be soon. So stay healthy and have a nice evening. Bye bye, everyone.